All right, so let's do a little introduction to this chapter. So it says that business information is often based on comparison of related quantities stated in the form of a ratio. Okay, so whenever you encounter business information, you'll have situations where quantities that are related to each other in some shape or form are going to be expressed in the form of a ratio. Okay, and we're going to see that as we go down. So further into this chapter, we'll see examples of that. Now, he's talking next. He says that when two or more ratios are equivalent, a proportion equating the ratios can be set up. So we can talk about a proportion that shows how they're related and how they're equated. Okay. So this is also useful in allocation problems, as we did some last semester, and we're going to encounter some more this semester. So allocation problems, such as distribution of costs or profit, or generally involve ratios. Okay. So are you going to distribute costs? You're going to distribute profit. We looked at some examples in our last big case that we did in our study, right? So, and just me drawing random things here. So allocation problems such as distribution of cost, profits generally involve ratios, and many of the physical, economic, and financial relationships affecting businesses may be stated in the forms of ratios or proportions. So we can express different problems that happen in business in the form of ratios and proportions. Okay, the fractional form of ratio is frequently replaced by the percent form because the relative amounts are more easily understood as percents. So what all this means, if you don't understand any of what I'm saying, don't worry. As you go down this chapter, things will become a lot easier, okay? So what he's talking about is like sometimes, like you want expressing something as 2 5 ratio 3.2, you just want to rather express it as a percentage. Um, Okay, this is routinely done in business reports and articles. You'll see that ratios are expressed in the form of percentages. Skills in manipulating percents, calculating percents, computing percentage rates, and dealing with problems of increase and decrease is fundamental to solving many business problems. Now, if there's anything you're going to take away from these courses, I really want you to have these solid skills in manipulating percents, And this does not mean like, this means like being able to work with them, calculating them, computing their rates, percentage rates, and dealing with problems of increase and decrease is fundamental to solving many business problems. So this stuff I want you to know like the back of your hands. This is something that we're gonna really focus on. There's gonna be lots of repetition around this, okay, in this course. All right, let's look at ratios. So setting up ratios. A ratio is a comparison of the relative values of numbers or quantities and may be written in any of the following ways. So is this basically like a comparison? You're comparing one thing to another thing, okay? So the example he gives is like, like you can use it as like a 5:2. Like you can say that like two armies are facing each other. This is one army, this is another army, and there's 500 men in this army and 200 men in this army. So the ratio of this army to this army is 5:2, and the ratio of this army to this army is 2:5, right? So they're not the same thing. When you're talking from the perspective of this army, the ratio is this. From the perspective of this, but ultimately, what it means is for every 5 men in this army, there's only 2 men in this army. Okay, and this idea can be used in other ways as well. So like for every 10 um, loaves of bread I bake for you, um, you give me, I don't know, you make 3 eggs. I don't know. It's a really bad example, but anyways, that's the idea. So let's look at let's look at how you can talk about a ratio. You can write a ratio like this. You can say an army is outnumbered 5-2, or you can say this, express the same idea 5-2 in this way, or you can express this 5/2, which is the same idea. You can also talk about it as 2.5, 5 divided by 2, 2.5 in decimal form, or you can express this as a percentage, it's 250%, which is basically just multiplying this with 100 and you get this. Now, again, don't worry about it if you're not understanding any of this. The point is just to get through this introduction, and once we get to the questions, it will become more clear. But this is just different ways you can express a ratio, okay? Next, there's 6 different points here that he wants to take us through. So the second one is when comparing more than 2 numbers or quantities, using the colon is preferred. To compare the quantities 3 kilogram, 3 kilogram, 2 kilogram, the ratio is written 5, 3, 2. 5 kilogram to 3 kilogram to 2 kilograms. So when two or more quantities are being when more than 2 quantities are being compared, it's preferable to use the colon method. This thing here. Okay. The third point is when using a ratio to compare quantities, their unit of measurement is usually dropped. Okay, so if everything is already expressed in kilograms, we're all talking about flour and it's all expressed in kilograms, well, we don't need to write kilogram next to it. We know it's all kilograms, so we can just write it as 5:3:2, just like he did here, okay? So the next thing he's saying is the number appearing in ratios are called terms of the ratio. So this is a term of the ratio, this is a term of the ratio, and this is a term of the ratio. If the terms are in different units, the terms need to be expressed in the same unit of measurement before the units can be dropped. Okay, so if, let's say this was 5 kilogram and this was grams and this was like, I don't know, ounces, we'd have to convert them all into a common measure. Either express them all as a kilogram or all as a gram or all as an ounce. All right. So in this case, he gives an example of, like, let's say a ratio of like 1/4 to $1. All right, 1/4 to $1. But we were not going to express it like that. We're going to first convert it all into cents. So 1/4 is 25 cents and $1 is 100 cents. So that's how we're going to do this. Okay, we're going to use the same measure, and then we can, now that we have both of these are these terms of the ratio, or using this terms of the ratio, or using the same units, we can express them without the units 25:10. Okay, so anyways, so there's that. Next, he's talking about the ratio 1/4 to $1 becomes 25 cents to 100 cents, 25 ratio 100, 25 to 100. The ratio of 3 hours to 40 minutes becomes 180 minutes to 40 minutes, or 180 to 40. So again, this is the same idea. Instead of saying 3 hours and 40 minutes, 3 ratio 40, that would be kind of wouldn't make sense, because this is in a different ratio and this is in a different ratio. So it's better to express this in the form of, okay, minutes. So 180 minutes, there's 60 minutes in an hour, so 60 multiplied by 3, 180 minutes, and ratio 40 minutes. This is what he's talking about, okay? When, as is frequently done, rates are expressed as ratios, ratios drop the units of measurements, even though the terms of the ratios represent different things. Okay, so now point number 5 is an exception to what we were talking about, point number 4, which is that we're trying to express everything in the same measurements. But when we're talking about rates, right, like rates is when, like, you talk about like 100, the train is going 100 kilometers per hour, or the prices are increasing at this blah 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 rate, or falling at this rate, or their wages are going up at this rate, or falling down at this rate, or whatever. Then in those cases, we have two different, we're probably going to have two different units of measurement, and that's okay. And that's, not only is that okay, usually when we're expressing them, we're okay to drop them. Now here we know this is in kilometers, and we know this is in hours, but we don't necessarily have to write it, because we're talking about, let's say, speed. So everybody knows that, this is not going to be expressed. Time is not expressed in kilometers, and distance is not often expressed in the form of seconds, right? So anyways, so in these cases, when rates are expressed as ratios, rates are expressed as ratios. So this is more than rates are expressed as ratios. Ratios drop the units of measurement, even though the terms of the ratio represent different things. Okay, so this is an exception to what we talked about in point number 4. Next, any statement containing a comparison of 2 or more numbers or quantities can be used to set up a ratio. Okay, so any statement where 2 or more numbers or quantities are being compared, we can set up a ratio. Okay, so this is something we'll see further as we go down further into the chapter. So anyways, these are 6 points. You're going to come back to them at the end of the chapter to review them. Right now, not all of them might make sense, and that's okay. That's not the point. But the point is that as we come back to this, it will make sense. So a ratio is a comparison of relative values, and may be written in any of the following ways. Okay, so that's a definition of ratio, and then they can be written in this form. When comparing 2 or more numbers or quantities, using the colon is preferred. When using a ratio to compare quantities, the unit of measurement is usually dropped. The numbers appearing in the ratio are called terms of the ratio. If the terms are in different units, the terms need to be expressed in the same unit of measurement. However, when rates are expressed as ratios, ratios drop the units of measurements, even though the terms of the ratio represent different things. And 6, any statement containing a comparison of 2 or more numbers or quantities can be used to set up a ratio. All right, boom. So that's good. Now let's go to the next page.